Right. Um, so someone over in Discord asked me for advice on how to wrap a C library, or in this case a C++ library, but with C compatible headers with Futhark. For those who don't know, Futhark is an uh, automatically importing C header libraries into NIM. And I have an example here, but I I keep getting questions like, how do I do this? How does it work? People not being able to make their wrappers. So I decided to do this live so that you can sort of see my process for doing this and how I wrap libraries using this. And hopefully you get a better understanding of how everything works. Um, so in this case, we're wrapping the yenc library, yencode, or rapid yencode library. Uh, Seems to be just some very optimized encoding library. I looked at yenc and it's literally just like add 40. What was it? Add 42 mod 256 with some extra stuff. Um, and Yeah, I think it's meant for sending binary data over platforms where nulls have to be escaped or something, or special characters have to be escaped, something like that. Not really sure. Doesn't really matter. So let's go ahead and grab this GitHub here. Just clone this down. Oops. So let's have a look. So basically the way that Futhark works, we need the header file. Futhark will read this header file during compilation, will create all of these definitions in a NIM compatible way so that we can use it in NIM. But it doesn't do anything about like how to actually link to the code, how to actually get the code to sort of talk to NIM, or the library to talk to NIM. This is done on purpose because sometimes you want to. Oh, am I a bit low? Someone told me to go louder. Is this better? It doesn't look very quiet on the mixer here. Maybe turn off your audio. Everything looks good from here. No. So yeah, the way it works, it doesn't do anything for sort of linking or building, integrating with the code. And that's done on purpose because sometimes you have weird workflows that don't really work, or that don't really do it the way that some tools require you to do it. And yeah, volume is proper. Okay, good. So yeah, this library to build or to sort of link against this library, we seem to be able to do sort of build an SO file, which is by far the easiest way to integrate with something like this. So we build cmake cmake, what was it, -- build here, and -- config release. And this should hopefully give us a SO file that we can link against. Harking or footing? Yeah, Futhark. I mean, Futhark is literally the alphabet, the runic alphabet. So turning it into a verb is kind of weird. but the proper word would probably be like scribing or something like that. Yeah, so there we have an SO file. Let's just go out here. We can create our rapidyenc nym file. And now, of course, we need to import Futhark. And we want Futhark to read this rapidyenc.h file. So we create an import C block, and our nym file now, I haven't saved it yet. Our nym file now lives in the same folder as the .h file. So I'm just going to say path dot. So this sets the path that Futhark will try to import, try to find libraries in to this folder, the folder that we're in right now, which is where this .h file is. And then we just say rapidyenc.h. This is basically just telling Futhark this is the file that we want to wrap. When we say we want to wrap this file, if you go and have a look, it includes some stuff. These are from the standard library. Futhark tries to find these by itself, and typically does a good job of that. And it doesn't import anything else. If it had imported sort of libraries local to itself, this path would be where it goes looking for those files. And Futhark will only spit out definitions for files that are found in this path or in this rapidyenc, or the header files that we specify here. That way we don't get all of the standard library C stuff wrapped, because a lot of that stuff is already wrapped in nym. If we now save this and we run a compile on this, cannot open. Did I mess up the name? Yes. So let's just close this file, close that, move this rapidyenc.nym. No. And then compile this. And we can see that a lot of stuff happens here. Futhark, I have my text size way up so it's easier for you guys to read. It's running the helper program upir, which spits out a JSON file full of definitions. Then Futhark reads that and generates a bunch of stuff. We don't have any errors, we don't have any warnings, so everything should be running nicely. Oh, and we need to open this back up again since we had it closed. I'm also going to open, so the rapidyenc library ships with this cli.c file, which I found in the README here. Cli.c is a simple command line application. That sounds like the kind of thing we can use as an example. So let's see what it does. Includes that. This part is done. Print usage, we don't need that. I'm just gonna do like a basic string. Let's see what this does. Right, so it initializes some stuff, but we can disable that. So if we don't run this, we don't do that. Here we go, encode. So it allocates rapidyenc encode max length. So let's create a input string, just a good old fashioned hello world. And it seems like our output should be the length of this thing. And we're just going to do output is equal to a new string of this length. And buffer size is going to be just the length of our input. In this example, they read into a buffer from standard input in chunks, chunks based on the size of this buffer. But we're just going to do our simple little string. It also has this line size thing. I'm not quite sure what that is. Let us have a look. Line size. Return the maximum possible length of yenc encoded output. So given an input of length bytes, this gives us the maximum possible length of the output. This function does also include additional padding needed. Does not require the init function to be called beforehand, but it does not say anything about what this line size thing is. But here we have a line size. The target number of bytes for each line, 128 is commonly used. Okay, so let's just do 128. We could, of course, do the same thing as they did in the C library. Just declare it as a constant. Line size, not line length. There we go. So now we're trying to call a function from our library. So let's see if everything still works. Oh, we got an error, type mismatch. Right, type mismatch. This function expects a C size t. We're giving it an int, and it doesn't like converting those without an explicit conversion, which is fine. Run this again. Right, so now the nim step completed, but when it tries to link our library, we get an error because we don't have any references. We don't link against anything that has this symbol in it. So what we need to do, we need to say, or we need to tell the nim compiler or the C compiler where or what we're trying to link against, so it can check that it can do everything it needs to do. So in our case, that lives in the build folder, and it's called, if you look in the build folder, it's called rapidyenc.so. So for GCC, that would just be rapidyenc, and it will add the lib and the .so automatically. So if we do that and run this again, right, now the compilation completed, but running our program. So our program is now compiled, it exists, but running it, we get an issue saying, we don't have this SO file, can't open it, no such file or directory. That just means that this is not in any path that our machine looks for SO files. Typically you would install these sort of system-wide, but in our case, I'll just tell our program that it should also look in this build folder for SO files. And there we go, no error. If we now just say the length of the output, which should be what this function here returns, compile and run. Let's just add this to here so we don't have to do both those steps at the same time. 88 characters. So given our hello world input, it says the maximum amount of characters I'm going to use to encode this is 88 characters. Nice. I'm guessing that's quite a detrimental case. And that would be 11 times the size. I got a question over on Twitch. It works with modern CPP too. What do you mean modern CPP? Futhark, as of right now, doesn't handle C++, but you can write a library in C++ and supply a C header and write your library in such a way that the only thing that's exposed through the SO file are C compatible functions, and that works fine. But it doesn't have any it doesn't currently wrap C++ at all. If you're trying to give it a C++ header file, it will just throw a bunch of errors. It has 66 bytes of padding. That makes sense. So let's go a bit deeper here. So it's a bit annoying having to write this rapidyenc over and over. Nim or C doesn't have any namespacing, so it's very common to just prefix all your functions with the name of the library. We don't have to deal with that in Nim, so I like to just remove these. So for that, I'm gonna give a rename callback and just call it rename, and it has this sort of function definition. So n is the name, k is the kind, and p is whatever it's part of, and we need to return a string. So if we just echo out the name, the kind, and the part of for now, and just return name back, we can see what we get. Right. So we get a lot of these constants. These are the defines. We also get some procedures, an enum, this type def. So typically you will see enums and structs first defined with a prefix, and then typed def to something without the prefix. But it seems if we just remove rapidyenc and maybe rapidyenc capitalized like this, we should get a much cleaner output. We could also do these, but here they seems to have shortened them, and I think I would like to keep these because AVX might probably be used somewhere else. So let's just import string utils, or let's do, just to make this a bit cleaner, standard library string utils. We're just going to say name dot remove prefix rapidyenc. There we go. And let's actually just do this so we can echo out the result before it gets returned. So in nim, remove prefix is only for characters. Oh no, it has a string version, but name is immutable. So we need to set result to be equal to name, and this doesn't return anything, it mutates. There we go. there. Now we can see that what we return, so for example, right, this this blank one is the part of the procedure, isn't part of anything. So rapidyenc decode init, rapidyenc decode init. So that actually didn't work because I once again mistyped the name. If you now run this again, right. So here we see rapidyenc decode init. Now it just becomes decode init. And let's remove the prefix of rapidyenc like this as well. Just don't echo out a bunch of stuff. Actually echo out the result just for fun. Right. So here is everything that comes out of our function: encode init, encode x. This looks pretty good. Again, these enums are going to be typed def. This is now just decoder state. Same for this one. This looks pretty good. This looks nice and clean. Clean enough anyways. Right. Of course, we now need to update this to reflect that change. And at the same time, we can just go from snake case to camel case. Since nim is style and let me actually just throw on this library path as well. Since nim is style and underline insensitive, it means that even though Futhark wraps this, so if we have a look, so it says caching the Futhark output in this file, and if you have a look in this file, it's quite a messy file because it does a lot of magic. You aren't really supposed to read this file. But yeah, as you can see here, we get underscores. We get snake case, the original casing. But since nim is style and case insensitive, we can just do this instead, which is pretty nice. But let us try to actually do something with this library. If you have a look at this CLI, now we have done this. Encode init seems to be our next call of action here. So as you can see, my Vim here is throwing a bunch of errors. Undeclared identifier. For some reason, nim LSP and all of the other sort of these other editor plugins don't really seem to like running. It doesn't seem to like Futhark. I think it's because when they are compiling stuff to find stuff or to find what symbols are available, they use their own temporary storage, and it doesn't run this big macro, and so it doesn't know of all of the symbols. That's my best guess anyways. If we do in this in the README for Futhark, there is a section on shipping wrappers here, which has this when defined use Futhark, else use this generated. This generally fixes the issues of the editor not being happy. rapidyenc. So do all of that and output the outputs into rapidyenc lib.nym, because we called this rapidyenc.nym. We don't want to overwrite it. something like that. And otherwise, if we don't say use Futhark or use Futhark for rapidyenc, then we'll just include this rapidyenc wrapper.env file. And we have to run it once with use Futhark and declare that identifier output. Output path, of course. There we go. Now we have this rapidyenc wrapper file, which is the same as this, the cache file that we opened just a second ago. And now if we run this without use Futhark, we will see that it doesn't run Futhark anymore. It just uses that pre-built library. This way you can sort of have this wrapper in your source control, and you don't have to have each user have set up the library properly, and yeah. But generally, don't edit these files. That's just a recipe for disaster. Futhark does a really good job of wrapping stuff. So as you can see, my editor is now much happier with the state of affairs. If I now actually mistype something, we'll get actual errors, which we can fix, and the editor stops complaining, which is nice. Let's have a look at this CLI program again. We had gotten down to, encode init. Initialize that. Then it reads in from the buffer. We don't do that because we just keep our stuff in a string. And this is what we want to wrap next. So it gives an output length. And right, so out length will be the actual output length. So let us do encode x. Remember, we stripped the prefix. Now we actually get inline help as well from my editor plugin. Column is, let's see, what is column? Right, so column just seems to be the start of, or sort of where, like how far we got. So let's just create and it needs to be able to update that, so it needs to get that as a pointer. In name, of course, that would be a var function. The data would be input, and here we need to do input 0.address. In C, a string is a pointer to a set of characters. So this will be the pointer to the first character in the string. I guess we actually could do C string as well. And we need our output as a C string. Read or read. Read is just how many bytes we actually have in our buffer. So in our case, that would be input.length, and eof end of file. I'm guessing that is just rv at the end of the file is an integer. I'm just going to go for no or 0, and this returns the size. So let us actually just do that immediately. Now I think my face might be in the way. So let's add some, check this stream for a sec. Yep. So I'm trying out this thing with a bigger box around myself. For those of you who have seen my Advent of Code streams, I have this like tiny circle, and I can't do anything. I can't show anything with my hands, which got kind of tiresome. So I decided to try for a taller box thing, but it takes up a bit more space. So yeah, if you like it, let me know. If not, I might switch back to the circle. Output set length. This will automatically set the length of our output string. So here we set the length of the output string to the max length. Here we set it to the actual length of encode x. And let's also echo the output. Type mismatch. Ooh, that's a bit hard to read. Type mismatch. Position 2. Address expects a pointer to an int. Or we gave a pointer to an int. It expects a pointer to a cint, which is an easy fix. So cint is just like whatever C calls an int, because nim and C have different names, or both use the name int. They mean slightly different things. In nim, an int is always the size of a pointer. In C, platform dependent. It can be anything, which is quite confusing sometimes if you're working on strange platforms. Right, so 5 here. This at position 5, that's length input. We supply an int. It expects a C size t, which is kind of like an int in nim. I believe C size t is always the size of a pointer. And there we go, 11 characters, and it seems we can't actually see all 11 characters. This is the binary encoding, so let me just cast this to a sequence of characters. In nim, a string and a sequence of characters is the same type. So if we do this, we get a different stringification function, which allows us to see the bytes more easily. And there we go. That's our encoded output. But let's have a look. We have more. Let's try to decode as well. Right, so encoding. We won't bother with CRC. Decode. So okay, we need to call decode init. We need a decoder state and decode incremental. Okay, let us try. Let's try var state is equal to RIDEC, which I guess is rapid y encode decode state, I guess. CRLF, so new line. And then it does the same thing. It reads in some bytes. We already have our bytes. And this is now the thing that we want to wrap, which should be decode incremental. And this takes a in pointer and out pointer. In pointer is a void pointer equals to the data, and data in our case is the buffer. So let's set these up. In pointer is equal to our outputs.c string. Out pointer is equal to the same thing for some reason. So it overrides. That's nice. In pointer as pointer, but it expects a void pointer. So let's cast this to just a generic pointer. The pointer keyword here in them is equal to void star. So in pointer dot address, that's a pointer. Out pointer address, that's again a pointer. Red, that would probably be then our output length, again probably as the C size, and state is the state with the address to this state. I guess it might be an enum, or let's check the output here. Rapidyenc wrapper. It doesn't find it. Redx state CRLF. So that's an actual enum. It's pretty nice. Oh, state CRLF. Oh, right deck, right. So that should be state. Oh. And this returns ended. And ended is rapidyenc decoder end. Let's just echo that out for now. Compile and run this. And right deck end none. I guess it ran to the end of the string. Let's assume that's a happy state. Yeah, and when looking at this, as I said, it's not really meant for human consumption. If you look at this, we have kind of a nasty bunch of numbers and a bunch of when size of when declared warnings and all of that stuff. If you want, you can turn. So when you're compiling, again, we need our use Futhark just to enter the Futhark block at all. And then we can say no declaration guards, which is like 90% of that noise. Cannot open. Try to delete that file. Maybe it doesn't want to overwrite it. Seems to have been the issue. Oh, maybe, yeah. Probably because I had it open in my editor. I didn't want to overwrite it as it was open. Yeah, as we can see here now, all of the numbers are gone. It still needs some of these checks. That is just because in C, so if you open the header file, in C, these are defines, and defines are just sort of expanding text, and we don't really have any type information for them. So here we're just trying to figure out what the type is. But as you can see, the file is now much shorter and just includes everything, only the stuff that we need. But sometimes it doesn't work. So the no decal guards is not the default because you're not supposed to be reading the output. You're supposed to just be looking at this, seeing how to use the library, seeing how you do it in C. And if you know nym well enough, you should be able to just write this as nym code instead. That's the idea anyways. Let's see. Where were we? Right. So we have apparently decoded our thing. And the out length. Ooh, here we need to do pointer arithmetic. So let's do output.set length. Human pointer. So the out pointer as a pointer, but we can't do math on pointers in them. So we need to do our math on actual numbers in them. Oh, and data is actually output.cstring. So yeah, I think what happens here is that when it decodes, it takes in a pointer and it does something to the output pointer. I think it sets the output pointer to where it stopped decoding or something like that, and then we check that against the output, and that generates a length. It's not the cleanest, but I guess this is the incremental function. So let's see what our output is. Oh, we don't need these anymore because we already have the wrapper file here with all the stuff in it, so we don't need to rewrap it. There we go. The output of that was hello world, which is what we put back in, or which is what we put in. If we just do this, we can also check that output should now be only hello world. Yep. No hidden characters, no extra stuff at the end, just exactly what we expect. So if we do this with the inputs, we can see those two are exactly the same. So we went through the input-output stuff, and we got out the same result. So we can do this. Let's just for fun echo the input at the beginning, echo the output, and down here just echo output. There we go. So as you can see, I changed this to a discard. I guess decode incremental is actually used to do something like you can restart it. We don't actually need the incremental. We could have just used this thing, and it returns the C size T as well. But we looked at the example instead. But everything seems to be working. We can keep these. Everything seems to be working. This is how you use Futhark. As you can see, it's pretty simple once you get the hang of it. I'm not sure how long this has taken me. I've been streaming now for about half an hour. Yeah. I'm not sure if anyone has any questions. I've been trying to answer them as I went along. If no one has any questions, then someone in the Discord tried the same thing. Tried to compile caching Futhark output and then a zigzag. Right. I might be cheating a little bit because I updated Futhark before I started this stream. So there is a fresh version out as of a couple of hours now, I guess. 2 hours ago. That fixes one zigzag bug, which I think is probably the one that you hit there. So if you just update Futhark to the latest version, that should be fixed. rapidyenc. I also struggle so hard with that name. I had never heard of it before today, and it is hard to both say and spell. I saw we had a warning that we didn't use str-utils, and of course we don't when we don't use Futhark, because we only use it for this rename. Yeah. I guess no further questions. Thanks, that was pretty clear. Got stuck at the beginning, compile filed, just the file. Yeah. As I said, I fixed the bug with enums. It's kind of a stupid bug. So it's been a bug that surfaced recently, I think, but I've run into it a couple of times. It's actually the compiler that fails. So if you run it twice, the zigzag will crash the compiler, but Futhark has already cached the output. So when you run nim again, it will read the cached output, and the cached output doesn't trigger the bug. So then it just works. So if you run it twice, then that bug doesn't appear. But that bug should be fixed now. Right. Is C++ support planned someday? At least a limited subset. C++ support is definitely planned. I have looked into it quite recently. I am not, or I have been paid to write C++ code in the past, but I'm not great with C++. So I'm not. The problem I have with updating Futhark to support C++ is that I don't quite know how nim wraps C++. I've never done that process manually. With Futhark, it was basically just writing down the rules that I was already doing when I myself was wrapping stuff by hand. But since I haven't wrapped any C++ code by hand, I don't have the knowledge to easily update Futhark to do the same thing. It shouldn't be hard. It's just figuring out all the rules. But I have found some small libraries that I might use for testing. If you have any other small libraries, stuff like this, rapidyenc, like if you have libraries of this size, which uses C++, and uses like namespaces and actual like C++ features, then I would like to know of them, because it would really help to serve as examples for the wrapping. But yeah, C++ support is definitely planned. Right. Yeah, so now we have Futhark version 0.13.4. That's good. Cleared the cache file. I'm guessing there's a but here, but it doesn't work. Still zigzag. Which nim version are you on? I'm using 2.08. Huh. You're also using 2.08. Don't really have any good guesses for what that might be. So you only have sort of, well, you don't have rename, callback, and output path. You just have path and rapidyenc. Yeah, no, that it shouldn't zigzag. It doesn't for me. Could you try just running it one more time and see if it works with the cache with the pre-cached. So even without this output path and this stuff, Futhark will cache the outputs into a folder or into your nim cache. Well, let's take that in the Discord, or as a GitHub issue, I guess. Remove the cache again, and now it works. Maybe. But yeah, once you get the hang of using Futhark, still zigzag. That is weird. Try not removing your cache and running it again. I think there might be a bug. So the zigzag, at least in my case, was coming from the nim compiler. It wasn't a Futhark or Upper bug, but it seemed to be triggered by something that I fixed. Second run undeclared identifier. That is the exact bug that I fixed. There seems to be something wrong with the versioning. Let's see. I pushed 2 hours ago. This tag points to this commit, and the parent for that is that was another bug. Yeah, that should. Did I forget to push something? Well, yeah, I'll get that fixed. We can take that in the Discord. So yeah, once you get going with Futhark, it's really easy to wrap stuff, and you can use C libraries in nim. Of course, they end up looking a bit C-ish. You need to do a bunch of casting and getting addresses like pointers to stuff and stuff you wouldn't really normally do in nim. But you can throw a template or something on there and make things look nice. That was everything for me today. Hope you enjoyed. Hope you learned something about using Futhark. And yeah,